Greetings to everyone. I am Dr. Raghav Agrawal, radiology resident at Krishna Vishwa Vidyapeeth. Today I'll be presenting on shear wave elastography in evaluation of solid focal hepatic lesions. So what is the purpose of this study? It is to analyze focal solid hepatic lesions by shear wave elastography and evaluation of its diagnostic accuracy in differentiating benign and malignant lesions. So what is the present knowledge? Shear wave elastography relies on the degree of lesion stiffness when subjected to external pressure. Malignant nodules have harder consistency, that is, less elasticity than benign ones due to the uncontrolled proliferation of cancer cells. Therefore, shear wave elastography has been investigated for differentiating benign and malignant nodules. Compared to conventional ultrasound, shear wave elastography is more quantitative and is less operator dependent, allowing more effective detection of malignant tumors. Recent diagnostic test accuracy studies and meta-analysis showed high sensitivity and specificity for shear wave elastography in detecting malignant lesions within the breast and hepatic tissues. The materials and methods used. This study included 50 patients who were referred to the radiology department at Krishna Hospital for focal hepatic lesions detected by grayscale ultrasound. All studied patients were subjected to grayscale ultrasound and ultrasound elastography. Point shear wave elastography was performed on Siemens Acusen Juniper ultrasound machine using a 2 to 5 MHz curved array transducer. The lesion size was measured in millimeters on grayscale, and point shear wave elastography measurements were acquired from the lesion situated best in the field of view. The ROC analysis was performed to evaluate the diagnostic accuracy of the stiffness value and lesion or liver stiffness ratio to extract optimal cutoff values for characterization of focal liver lesions. Benign and malignant lesions were confirmed by histopathology and/or imaging studies. So case 1, 65-year-old male with right upper quadrant pain diagnosed to have focal liver lesions on ultrasound. Histopathology showed well-differentiated adenocarcinoma metastasis. So what are the elastography parameters? Stiff value of lesion is 20.7 kilopascal and strain ratio was 5.5. Case 2, 68-year-old male with upper abdominal pain diagnosed to have focal liver lesion on ultrasound. Histopathology showed hepatocellular carcinoma. So the elasticity parameters were stiffness value of lesion was 52.9 kilopascal and strain ratio was 3. Another case, 35-year-old female with upper abdominal pain diagnosed to have few focal liver lesions on ultrasound. Histopathology showed hemangiomas. Elastography parameters were stiffness value of the lesion was 12.0 kilopascal and strain ratio was 1.0. Another case of 40-year-old female with upper abdominal pain diagnosed to have few focal liver lesions on ultrasound. Histology showed focal nodular hyperplasia. The elastography parameters were stiffness value of lesion was 11.6 kilopascals and strain ratio was 1.6. So benign lesions showed a low strain ratio while malignant lesions showed a high strain ratio. The mean ratio in the benign lesions was 1.02 with variable of 0.5, while the mean ratio in the malignant lesions was 4.1 with a variable of 1.3. The cutoff value used to diagnose the malignant lesions and differentiate these lesions from the benign lesions was 1.8, which had a sensitivity of 100%, specificity of 93.1%, positive predictive value of 97%, and negative predictive value of 100%. So these were the references I used in the study. Thank you.